So, absolute value. If I say absolute value to you, what does it do? What does it mean to you? Makes everything positive. If you remember that, you can do an absolute value transformation. Okay? Because we know that the absolute value graph looks like this. Correct? What that actually is a transformation of this graph. What does the graph of y is equal to x look like? Anybody know? It's a straight line with an y-intercept of 0 and a slope of 1. That's what we reflected our inverses over, right? Now, that's y is equal to x. If you put an absolute value around it, it makes everything positive. So if you're already positive, it has no change, correct? And it's making the y values positive. So this part of the graph here stays the same. The only part that changes is the part that's below the x-axis. And all it does, if this is a y value of -1 right there, it becomes +1. -2 becomes +2. -3 becomes +3. That's why you get the V-like shape, okay, of an absolute value graph. That's why it looks like that. That's all it is. Whatever's below the x-axis becomes positive, all right? So we can do this to parabolas. So we have x squared minus 4. And you all remember from grade 11, it is a parabola that's been shifted 4 units down. Anything that is below the x-axis, because it's reflecting the y values, is negative. So everything above it, this bit, stays the same. If we're at -4 here, where does that go to? +4. So the graph looks like this. Oh, I drew it at 5. Sorry. There we go. Boom. There you go. There's your graph. All an absolute value graph does is flip the graph. Anything that's below the x-axis just flips up. If you're already above it, you stay there. So this is the graph of y is equal to the absolute value x squared minus 4. That's all an absolute value graph, absolute value transformation does.
Anything that's like below there,
you flip it up. If it's at -4, it goes to +4. If it's at -5, it goes to +5. All right, we ready for the next page? Okay, peoples, here we go. So, here's the graph of 1 minus x squared, which is a parabola that opens down but's been shifted 1 unit up. Okay, we're going to do the absolute value transformation. So we put these absolute values around it. Anything that's above the x-axis stays the same. So this part of the graph stays the same. What happens to the stuff below it? That's the graph. Doesn't have to be a straight line. It's based on the original graph. So because the original is curved, that'll be curved. But that's okay. I just want the general shape. That's all I'm going for here. So this is the graph of 1 minus x squared, absolute value. That's it. That's all you do. Going once, going twice. We're going to do the one right below it. This thing, this thing, whatever this is, A. We're doing the absolute value of that graph. What's the only part that changes? The stuff that's below. And if that's at -1, so it goes up and it goes. Ooh. That's all an absolute value transformation does. Anything below the x-axis becomes positive. How do we feel about that? Is that better than reciprocals? Okay. Now we're going to combine it with reciprocals. This is the last thing we're doing. So we're going to go back to the top right one here. Okay. We have the graph of 1 minus x squared, all absolute valued. It's the red one. Now we're going to do the reciprocal of it. When you're doing a reciprocal, what's the first thing you mark? X-intercepts, which are the vertical asymptotes. So we're going to mark those. They are at 1 and negative 1. So I'm just going to mark them on this graph. X is equal to 1. X is equal to negative 1. Okay.
How do we know that?
Because it's the y value of 0. And you go 1 over 0, which you can't divide by, right? It's what makes the denominator equal to 0.
Okay.
So if I said what makes this denominator equal to 0, it's plus minus 1, right?
Yeah.
Because then you get 0.
Okay.
That's what it is. That's what a vertical asymptote is. All right. What's the horizontal always for now? So we mark that. Okay. What points don't change? Plus minus 1. Y values of plus minus 1. So if you look at the original graph, right there has a value of has a value of 1. So that point stays the same. Okay, I told you, when you're between two vertical asymptotes, what shape do you get? Parabola-like. I don't want to say parabola because it's not actually a parabola, but it's parabola-like. We're between two vertical asymptotes. So the only thing the graph can do, you can't touch that, can't touch that, can't touch that. So it goes like that. I'm only looking for the general shape. Get the verticals, get the horizontals, get the invariant points right, and the general shape. I will be happy. All right, now we got to do the outside ones, right? Because we drew this part of the graph, which is there. What do the outside ones do? They do the sweeps. I don't know what to call them. I'm just calling them sweeps. So it looks like this. So that is the graph of 1 over the absolute value of 1 minus x squared. There's a little bit in every unit, but there's 2 or 3 units that are heavy graphing. This would be one of the heavy graphing ones. All right, last question. I'm doing the absolute value of this, or the 1 over the absolute value of this graph. This is the absolute value graph. I want to do 1 over that. What do you mark first? Vertical asymptotes, which are at your x-intercepts. Negative, what is that? Negative 1.5? 3 over 2? Whatever. Where's your horizontal? 0. So mark that. Where are your invariant points? Negative 1 and positive 1 for y, right? Okay, so mark those. There's a 1 right there. I'm going to do this in a different color, actually. Blue. So 1 right there. And then if you look at this part of the graph, it's out all at 1. So that part won't change. Okay. Let's look at this. That's at 3, right? Does everybody agree that's at 3? If you do 1 over that, where does it move to? So I'm just going to call this a third. Okay. Yeah, you're supposed to draw it on the other one, but I'm drawing it on this one. The blue stuff is your graph. I can draw it over here if you want. No, I'm gonna draw it. That is your graph because you get it's the two sweeps. This thing, because it's not between two vertical asymptotes. What? Hmm?
I said that looks like a map. And then all the one ways in Victoria. And then I started talking about traffic in Victoria.
So we're okay. So we're way off topic. Okay, I just got to write one last thing and then we're done. Next page. We're not. It's not a graph, so we're not doing this. Okay. All right. Remember, I gave you the order of operations on Friday or Thursday for transformations. We're gonna tweak it a little bit. Okay, here we go. Yeah. So if you have absolute values and reciprocals in your function, it sort of tweaks the order. Always start inside the absolute value. And work out. So you start inside of it and you work your way out. Think of them as brackets almost. Okay. Reciprocals are always last. That's the difference. If you have an absolute value, you start inside and you follow the rules and work your way out. If you have a reciprocal, reciprocals are always done last. So if you have something that looks like this, you have y is equal to 1 over f of x plus 4 absolute valued minus 2. Okay. If I gave you this, and I said sketch. Actually, let's make this. Let's do that. Okay. So f of x plus 4 absolute valued minus 2. So I asked you to sketch this graph, okay? I gave you the original. I said do these transformations. You start inside the absolute value and you work your way out. So inside the absolute value, what would be the first transformation you run into? Minus 4. So we're going 4 to the left. So your first step would be 4 left. Then you start to work your way out. The second thing you run into is what? Well, the f is just represents the function. The absolute value. So the second thing when you're working your way out is the absolute value. So then that's the second thing you do. Then, now you're on the outside of the absolute value. What's the next thing you hit? Which tells you to do what? Go down 2. And then what is the final thing? The reciprocal. And you know it's a reciprocal because it's 1 over. Okay? That's the last thing you do when you're graphing it. So if you had the original graph, you would move the original graph 4 units left. then you would absolute value it, then you'd move it 2 down, and then you do the reciprocal. Okay? If you have an absolute value, it's telling you to start inside there and work your way out. Okay? That is it for this unit. 1, 3, 4, 6 to 8. 6 to 8 is just multiple choice. You're matching graphs. You got 8 minutes. Yeah. Where did I record that lesson? 1, 3, 4, 6, 8.